Relative position of two lines in space. Two lines can be parallel. Direction vector for parallel lines are scalar multiple of each other. Two non-parallel lines can intersect at a point. And there's a third option. Two lines can be skew. Skew lines are not parallel and they do not intersect. So let's view, here are a pair of parallel, here are a pair of intersecting, and a pair of skew lines. And so as you see, parallel is what you're expecting. They don't intersect each other and they have the same vector, direction vector. Here L2 and L3 have different direction vectors, and they don't intersect. Here L1 and L4 are the green lines, are basically intersecting. Here parallel, intersecting right there, and here are the skew ones. Example 3. The two lines L1 and L2 given by the equations L1 equal to x equal to 3 minus 2t, y equal to 1 plus t, z equal to 4 minus 3t, and L2 equal to is the line x equal to minus 5 plus t, y equal to 4 minus t, and z equal to 1 plus 6t. These are the two parametric form of the two lines. In these two lines, if you look at how do I find the direction vector for the first one, one direction vector for the first one is what multiplies t for x is negative 2, goes right here. 1 multiplies t for y is 1, goes right here. 1 multiplies t for z is negative 3 and goes here. And for L2, what multiplies t for x is 1. What multiplies t for y is negative 1. What multiplies t for z is 6. These two are not scalar multiple of each other, so L1 and L2 are not parallel. So out of the two types, so this one is out, parallel out, and two types left. Either they intersect or they're skewed. They're two skew lines. And so let's see, how do we figure out if they are intersecting or not? So let's dissect it a little bit. R1 or L1 is if you write it in the vector form, is basically the point, things that didn't have t, plus t times things that had t. So you can dissect it that way, and R2 also the same way. Now, what is remaining is if these two are intersecting or not. To do that, remember, the t in one line can be, for the same point, can be different from td in the other line. So the best way to deal with this is to switch one of the t's to another variable. And so basically, what you do is you take x value for L1, which is 3 minus 2t, and you set it equal to x value for L2. Instead of t, you use s. And then y value for L1, which would be 1 plus t, and then set it equal to y value for L2, which is going to be 4 plus, and change t to s again, negative s, and so on, and z same way. So what happens is that this is 3 equations. How many variables? 2 variables, and they're linear equations. You can solve t and s in two of the equations, let's say equation 1 and equation 2, and then plug them into equation 3 to see if they actually satisfy equation 3. And that means that there is a point that is in common between L1 and L2. If it doesn't satisfy, if you cannot solve these three equations for two variables, then there is no point, and the two lines are skewed. So it turns out t equal to 5 and s equal to -2 actually satisfies all three equations, and that means that now, to find the point of intersection of the two, you have to either plug in t equal to 5 in L1, or you have to plug in s equal to -2 in L2. They should both give you the same solution. See, R1 of 5 or R2 of -2 should be the same. And that's the point of the intersection. So these two lines were intersecting. If the system didn't have any solution, the two lines would have been skewed. I click at question E. What is the relative position of the line L1 defined by R of t equal to 1 minus 3t and t and 0, and L2 defined by 2t, 1 and 1 plus t? Options are A, L1 and L2 are the same lines, B, L1 and L2 are parallel, and C, L1 and L2 are orthogonal, D, L1 and L2 intersect, E, L1 and L2 are skewed. So now that you worked on it, let's work on it together. Are they parallel? The direction vector for this one is -3, -3, 1, and 0. For this one is 2. What's multiplying t in the second one? 0 and 1. So the two direction vectors are not parallel, are not scalar multiple of each other. Therefore, the two lines are not parallel. So not parallel. This one's out. Are they the same line? If their if their direction vector is not parallel, then they cannot be the same line for sure. So that one's out. Are they orthogonal? Let's multiply this is when two vectors are orthogonal to each other. If their dot product, if you remember that part, this is very important, is dot product is equal to 0. So let's calculate the dot product. -2 times 2, -3 times 2 is -6. 1 times 0 is 0 plus 0. This is non-zero, so not orthogonal, out. L1 and L2 intersect, or L1 and L2 are skewed. That part you have to solve now. So how do I solve? Let's get rid of everything else. And so I have to set this equal to that with, let's say, 2t equal to 1 minus 3s. And then set these two equal to each other. Again, change the, I changed this part to s. And so it would be 1 is equal to s. And then the last part is the z values. 0 is equal to, so I'm going to set 0 equal to 1 plus t. And so solving from here, s has to be from these two. These two are the easy one. S equal to 1, t equal to -1. Let's plug it back, these two values back into here. So what do I get? I get 2 times -1 and 1 minus 3 times 1. Oh, it turns out that two of these are the same values, so they actually intersect.